What's up, everybody? Welcome to the Comet ML Office Hour. We are on session 2 of an 8-part session talking about standardizing the experiment. Hopefully, you guys got a chance to join in on this session last week. We spoke to my good friend and I guess we could say colleague, counterpart at Anaconda, Christian Capdevel. That was a really great conversation where we discussed how to translate a data science and machine learning problem into a business problem, and then also how to communicate with the business and make sure that we're getting alignment for machine learning projects. Today, we're going to continue on that theme of standardizing the experiment, but we're going to talk about defining scope and success criteria for your machine learning projects. Hopefully, you guys got a chance to tune into the blog post if you're on the email list and if you're registered for this session. You would have seen that. If not, no worries. We'll send you a registration link right here in the chat on LinkedIn. If you're watching on LinkedIn, we'll get you that chat. That way you can stay up to date on all the blog posts that we're publishing, all the supplemental content that we're going to be sending out to really help drive these points home for all you guys. So let's go ahead and get started now. Today, we're going to talk about defining scope and success criteria. So let's go ahead and jump right into the slides. Those of you guys tuning in on LinkedIn, if you got questions at any point, go ahead, drop your questions right there in the chat, and we'll be able to get them queued up. So no worries about that. Questions or comments are all welcome. Let's go ahead and get right to it. All right, so let's talk about it. Defining scope and success criteria. So this is the second session of a series of sessions that we're doing about standardizing the experiment. So today we're going to talk about defining scope and success criteria for your machine learning projects. I've heard this said a lot of times, and I think it can get annoying, it can get frustrating as a practitioner and as someone who genuinely loves this field and the work that we do. People just keep saying machine learning is like the Wild West. There's no standardization. You guys are out there doing whatever the heck you want. I get it. The industry standards are sparse. Forget the industry. I think even teams within the same organization could have drastically different methodologies for approaching how to build and maintain a machine learning system. So we have to do better than that. I think we have to get to a point where we get some more standardization. And so that's what we're going to talk about today. So reproducibility in machine learning. So I think the only way really we can ensure reproducibility is making sure we standardize the experiment. So it's what makes machine learning so exciting and unique. It's the same thing that makes it so hard and challenging and at times frustrating, because not only are we dealing with code, but the work we do is entangled with a host of upstream dependencies. The size of the data set, the distribution of the features within the data set, data scaling, splitting techniques, optimizers, what type of optimizers are we using? The list goes on and on and on. And if you couple that with the fact that machine learning is really experimental, it's inherently by nature experimental and iterative science, that means that we need to be a bit more diligent when we track multiple sources of variability that can creep in. We need to be able to track them, identify them, and manage them. It is hard to standardize these processes, but at the same time, it's super easy for us to make mistakes at any stage of the machine learning life cycle. And those mistakes could cost the company a lot of money, could cost the reputation, so on and so forth. So even though it's hard to standardize the process, just remember it's easier to make mistakes. So we got to do science a little bit better. I think experiments are a key component of the machine learning lifecycle. And the experimentation process, it should include a lot of rapid iteration over different model types, data transformations, feature engineering choices, whatever various optimization methods that you're using, all to understand how changes of any size affect the output of your system. Because you'll hear this phrase used a lot throughout this series. It's the CASE principle, CACE. Because if anything is true, about machine learning is that it abides by this principle, the case principle. So what is the case principle? Case principle means changing anything changes everything. So it's just a phenomena by which anywhere in the machine learning process, especially those furthest upstream, will have an unanticipated impact on your experiment and results. It's not only changes during the model development process that are affected, because once your model is released into production, it's in the wild. It's out in the wild. It's dealing with real world data. It's being served to people, and it's changing behavior. So there's changes that happen on both ends. But during training, after training, in deployment, the world will change. Your model will need to change in reaction to that. But there are two key habits that we can practice that, if we practice them consistently, will really help set us up on a path towards reproducible and explainable production-ready machine learning models. One is keeping track of all experimental metadata. And that could be a number of different artifacts that you generate through that process: code, metrics, hyperparameters, data sets, samples, predictions, visualizations, models, etc. These are all things that we need to keep track of to have that lineage from ideation to production. Second is logging everything to a central repository in a systematized way so that we can compare analyses. So keeping track of experimental metadata is necessary for a consistent and repeatable experiment process. They're critical steps, these two, that when you adopt them, when you practice them, when you get into the habit of doing these, it's going to enable data scientists, machine learning practitioners, and just data science teams as a whole to achieve more consistency as part of the process. And if you keep that at the forefront of your mind when you're working, rather than an afterthought, you'll find that it'll be easier to reproduce the work you're doing and explain it and track changes. So you guys probably thinking, you're talking all this stuff about experiments and how hard it is and how iterative it is. I thought we're going to discuss defining scope and success criteria. We are. Let's go ahead and get right into that. So what we're going to talk about today. So these are 4 things we're going to touch on today. We're going to talk about defining success, defining scope, how to scope, and questions that you should be asking as you're going through this process of scoping. So let's start off by defining success. So this is really one of the first questions you should be asking yourself when you embark on a machine learning project. What will success look? So you might be spending weeks, your team might be spending weeks, months, even longer working on a project. And without a clear definition of what success looks like, you'll be spinning around in circles in a never-ending cycle of more work, more features, more stuff, going down 100 different rabbit holes. So just right at the start, just define what success is going to look like. And typically, success will be measured by some metric that's directly, at least trying to relate to the business, and usually involves a combination of improving, maximizing, increasing, decreasing, mitigating, or reducing that metric that you guys are interested in. So to find out exactly what that is, you'll have to start asking some questions. For example, what's the business objective that you want to accomplish with the model? Do you want something that beats the current model in production? Are we creating models with the goal of increasing revenue in a specific way? Are we trying to increase traffic or trying to increase active users? These are just some examples of questions that you should be asking at the start, because once you clearly define the outcome you're trying to achieve and what success looks like, and ensure that those target outcomes are measurable and achievable, you'll find the whole process becomes a little bit less ambiguous. There's still going to be ambiguity there, but having these things clearly defined up front will make it easier to know when you should stop. So if you do this, you're going to be leaps and bounds closer to actually delivering business value. So you find that through this process, of defining success, you'll more clearly articulate the problem statement, as well as ensure that you're expending time, energy, and resources on a problem that is actually worth. And for those of you working on a portfolio project, for example, maybe you're not in a business, maybe you're just working on a project just to develop your skills, just to gain some experience. Even if you aren't solving that particular business problem, it's important to define upfront what a successful project looks like, because it forces you to get into the habit of thinking things through and planning before you start to actually do things. So let's talk about defining scope. So before writing any code or looking at any data, you must be able to clearly state and quantify the scope of your project. Imperative that you ask questions before you jump into coding and developing a solution. So scoping means that you're picking the right project to work on. And so what do we mean by right project? It means that you're finding a project or undertaking some endeavor that solves real problems. That's not only does it solve a real problem, but that problem is actually solvable. And you can take actions to help solve that problem. So clearly defined problem statement that doesn't have a business impact means that you're going to encounter a lot of lackluster enthusiasm for all the effort that you are putting in. So ideally, you want to work on a problem that's a priority for your organization. And if it's not a priority, then it doesn't matter how awesome your model is, no one in the organization is going to be motivated enough to act on the findings of your work. So defining the scope of a project means asking a lot of questions. And again, keep in mind that this is a very iterative, it's an often non-linear process. But through this process of scoping, you're going to be well on your way to determining whether all your efforts are going to solve a real, tractable, actionable problem. So I'll pause real quick, see if there's any questions coming in. I don't see any questions in the chat, don't see any questions on LinkedIn. So let's go ahead and keep moving to the next slide. So scope, how do you even scope a project? So you can begin scoping a project by just asking your stakeholders to just describe the problem that they're facing. So get as much detail as you possibly can about who, what, why, and how much people, processes, or profits will be affected if this problem is left unsolved. And find out what they're doing or what they've done previously to try to solve the problem already. And try to find out why it's important to solve that problem right now rather than later. So when you have a clear understanding of how the organization has already tried to solve the problem, you'll be better able to at least identify ways for machine learning to help the organization achieve its goal. So I'm a huge fan of Andrew Ng, godfather of machine learning, and I was recently in one of his Coursera courses, Introduction to Machine Learning in Production, I believe it was. And he has a really great 5-step process for scoping a project. And we're going to go ahead and discuss that briefly right here. So the first thing that Andrew recommends is brainstorming the business problem with the stakeholder. And at this point, the brainstorming point, you just focused solely on identifying a business problem, not a machine learning problem. So the mindset that Andrew recommends adopting here is you go into this meeting and brainstorm solutions and say, hey, look, I don't want to hear about your AI problems. I want to hear about your business problems. And then it's my job to work with you to see if there's an AI solution that we can use to help solve this problem. And so once you've had this conversation with the stakeholder, then you move on to the next step, which is the brainstorming of actual AI solutions. And so Andrew recommends taking a page out of the design thinking playbook and keep the identification of the problem separate from the identification of the solution. because it's always easy to come up with just possible solutions, but clearly articulating the problem will lead to solutions. And once you've brainstormed a variety of different solutions, the next step is to assess the feasibility and value of potential solutions. So, what you want to do here is double check that your brainstormed solution is technically feasible and valuable. The next steps Andrew recommends is determining milestones for the project, and then finally budgeting for resources. And I really like this quote that Andrew has in the course, uh, and I'll quote him here. One thing I hope you avoid is working really hard on a project and creating a certain amount of monetary and social value if for the same amount of work, there's a different problem that could have created 10 times more positive value. And I think the scoping process will help you do that. So, answering these questions involves talking to a wide variety of stakeholders that are involved in your project and developing a shared understanding of the objective of your model and then the evaluation process for your model. So here's some questions that you might want to answer at this stage of the process. So the ability to focus, scope, and define success criteria for a project is the mark of a solid senior data scientist. So going through this process requires foresight and will help you determine whether you're working on the right problem or not. So as Andrew Ng says, picking the right problem to work on is one of the most rare and valuable skills in AI today. So if you're going to spend a lot of time on a project, it's worth putting in some time up front to think through whether it'll be worth your time and whether it has some chance to succeed. So here's some questions you might want to think about asking. What business objective is your model trying to achieve? What are the KPIs for your task? What is the specific task that you're trying to automate with machine learning? How will end users interact with this model? What's the input to the system? Is there a risk for our model or data to be biased? If so, how do we detect this? What's the expected output? How will you measure that your model is actually working? How do you know if you can trust these predictions? How important is it for your model to be interpretable? Where will this model be deployed? On premises, on cloud, on mobile edge devices? And what information will be exposed to your users? So that's a short presentation for today. We'll go ahead and tune into some questions. And I also want to take a minute to show you what this looks like. And how you should have received this in the email. But for those of you that didn't get a chance to check the email, we'll go through this document quickly here. But that's it for this part of the presentation. Next week, we're going to talk about how to build baselines, but more on next week once we get through some questions and see what the scoping looks like in action. All right, so I'm going to pull up something that you guys should have gotten in your, but before I get there, let's go ahead and see if there's any questions coming in from the chat. Somebody's asking, please share what the rare and valuable skills a data scientist should have in your opinion. That's interesting that you asked that question because I just talked about Andrew Ng's, what he said was the most rare and valuable skills. And that's the ability to pick the right project to work on. I think that is a definitely a rare and valuable skill. So let's go ahead and pull this up. Should have seen this in you guys' email. If not, don't worry. We'll have a link out for you. But one of the kind of toy projects that we're going to be working on through this process is the Hacker News performance prediction. And here we're going to show you how you should go through scoping a project. So right here, this was created by my colleague Dhruv, and it's just an outline of the requirements to build topic identification, classification, and performance prediction models based on data collected from Hacker News submissions. And you'll see here we've got the objective clearly outlined. We've got the model objective clearly outlined as well. We're also thinking about ethical requirements, and we're thinking about model requirements as well. And we're leaving notes for ourselves, different actions and evaluation metrics, and how we're going to evaluate the effectiveness of each one of these different types of models that we might want to play around with. So you see here, it's answering a lot of questions. And that's really what it comes down to, because the more questions you ask and the more answers you get, the better clarity you're going to have on what it is that you actually should be doing and what constitutes success, and what's going to move the needle on any initiatives. So this is pretty much what a scoping document, you can call this, looks like. And you can see here, we're asking a lot of questions and getting answers to those questions. So this will be sent to you in an email if you've already registered for the session. But if not, I'll go ahead and drop a link to it right here in the chat. I'd love to hear from you all that are joining us here on the Zoom room and on LinkedIn as well. Let's open it up for questions. So next week, we're going to talk about how to tell if you built a good model. And that's all about baselines. And we're going to have a interview with a practitioner from the community. It'll be a great talk. We'll learn a bit about her background and how she approaches machine learning projects. And yeah, I'm looking forward to it. It'll be a great chat. So tune in for that. We'll have the accompanying blog post and other resources sent out to you as well. I think one thing to really quickly talk about is feasibility studies. So I guess let's quickly touch on that. So this is something, I believe this was, I can't remember where it was that I found this document, but I found it too late to include into the blog post or into the session. And I'm pretty sure the author of this was Vin Vashist, but let me go ahead and pull this up. And this is all about feasibility studies, right? So what are we supposed to do for a feasibility study? So that's something that we had talked about as part of this project scoping criteria. I'll go ahead and just read this off to you, but the main goal of a feasibility study is to assess whether it is feasible to solve the problem satisfactorily using machine learning with the available data, right? And you want to avoid investing too much in the solution before you have sufficient evidence that an ML solution will be the best technical solution, before you have sufficient evidence that an ML solution is possible, before you have some vetted direction on what an ML solution should look. These are all things you should think about, because this inches you closer and closer to finding the right project to work on. You don't want to spend a lot of time working on a project only to find out that it's not even feasible for you to solve it using machine learning. This is a great document. I guess I could share this with you guys as well. Pretty sure the author of this was Vin Vashista, but I do not remember where it was that I found this, but definitely a useful document that I highly recommend checking out. I've actually posted this on LinkedIn. I think it might've been last week. So definitely check that out. So let's see if you guys got questions, man. Open it up. I see the chat has some activity going on. So Alim is asking, you missed last week's presentation. Is it available somewhere? Yes, it is available. It's actually available on the Comet YouTube channel. I'll have one of my colleagues from Comet go ahead and drop a link to that. All of our videos are going to be saved on LinkedIn, on YouTube. They're going to be broadcasted live on LinkedIn and saved on YouTube for you to visit and check out. Somebody's asking, are we going to cover basic things in this course, like how to write programs? No, that's not the purpose of this course. So a lot of the topics that we're going to be discovering and touching on during the course of the office hours, they're going to be more advanced concepts. So definitely nothing for the 101 level type of stuff. And as Emily is mentioning, next week we're going to talk, not to say that you won't benefit from it. I think beginners should have an eye towards the horizon, so to speak. What are some of the issues that you should be thinking about, even if you don't really have like the full skill set or set of tools at your disposal to do machine learning quite yet? It's very important to think about the challenges that you might face. Yeah, next week we have Dr. Angelica Loduca come in. I'm excited to chat with her. I've got a lot of great questions queued up for her. She's done a lot of awesome writing on Medium, so I highly recommend checking her out. Somebody is saying it'll be nice to see me do this live, the scoping part live. Yeah, so we've got that scoping document. Hopefully that gives you an idea of what the scoping process entails. You'll see us at Comet do some more from the ground up live projects, building in public type stuff further down the line this year. I think it'll be a lot of fun, so definitely keep an eye out for that. So in the Hacker News scope example, the topics are already fixed and known. This is not necessarily representative. Steven, so go ahead if you got a question. I see you got your camera on, so go ahead. Let me know. I'm not sure what you mean by that.
Yeah, sure. Yeah, thanks for the talk. But the topics fixed number and they're already known. That's not necessarily represented as if you're looking at, say, sentiment of reviews. If you launch a new product, people might say the battery life sucks, or I don't like the bezel, or the color is bad. You don't know up front what the topics are. Just pointing out that having a fixed number of known topics makes it a much easier problem.
Yeah, definitely having that kind of constraint up front will definitely help it. Again, this is just for illustrative purposes. So here, like, I'll pull this up here for what we're talking about. Here we're just brainstorming, creating. That's what we're doing during the scoping process. But for the topic model, this is what we're trying to do: some sort of clustering method. And if we were to go down this route, the whole point we're trying to do is, okay, is a topic model feasible? If we were to attempt to solve this problem that we've outlined up here using a topic model, how would we go about doing that? How will we assess the performance of our model? But yeah, like, we don't know the topics up front, but we still cluster and identify topics, and we don't need to identify a million different topics. There might just be 5 or 6 key topics that tend to cluster together that we might be interested in. But yeah, the whole point of doing a document like this is to identify questions or issues as you've highlighted. So we'll go ahead and stop the live broadcast then. Thanks, guys, for joining on LinkedIn. Cheers. And as I always say, you got one life on this planet. Why not try to do something big?